All right, so we're going to talk about Lecture 3. Pen doesn't work. Try again. Lecture 3. What are we going to talk about? Limits. Limits, specifically from a graph or a table. All right. Now, what is a limit? I guess that's the first thing we need to talk about, right? So here's the idea of a limit. Well, and the notation. So the limit of a function f of x as x approaches a is written this way. So here's how you write a limit. Okay, that's how you write. So the limit of a function f of x as x approaches a. So you need to be able to read all the little pieces here. So right, this is as x approaches a. Obviously, there's where it says limit. So limit of f of x as x approaches a. Right, so that's the notation. Now, what is it? Well, there's precise definitions, and then there's also kind of just the idea. So let's talk about the idea. So the idea is this. Idea. Let's see. If you trace the graph of f of x towards x equals a, and you get to the y value of L, then the limit as x approaches a of f of x equals L. Okay, now that's not the definition, that's just the idea. So let's look at a couple of graphs here to see if we can just figure it out from a graph. So I'm going to put like 3 right there. I'm going to put 1, 2, 3, 4. No, I'll just put 2. Okay. So let's put a dot right there. And then let's do that. And let's do that. Okay. Now, if I ask you, if I give you this picture and I say find the limit as x approaches 3 of f of x, it's very easy. All you've got to do is basically just exactly what I said up here. Trace the graph of f of x towards x equals a. And the key there is that you're tracing the graph. You're not just, you're not down here. This is not what I'm talking about. Okay? You're supposed to be tracing the actual graph of the function. So when I say trace the graph towards x equals 3, of course, this is x equals 3, right? But you're tracing the graph of the function. So if you're up here on the graph somewhere and you head towards x equals 3, you would be tracing this portion of the curve, right? And where do you end up? You end up right at that dot. Now, if you start out on the other side of 3 and you head towards x equals 3, then you'd be heading this way. Where are you going to end up? You're going to end up at this dot again, right? So from the left and from the right, either way, you end up at x equals 2, right? Or sorry, y equals 2. So when you trace the graph, you end up at y equals 2. So what is this limit as x approaches 3? 2. All right, so that's how you do it from a graph intuitively. Now, why do you have to trace it, right? Why do you have to trace it? We knew this dot was right here, right? 3, 2. If it's at 3, 2, and you know that the x value is 3, and you know the y value is 2, then why are you even tracing the graph in the first place? Why trace graph? Okay. The reason you have to trace the graph is because the way that I worded this here is you trace the graph towards x equals a and you get to a y value. I didn't say anything about there being a dot there, right? So right here, there's a dot at 3, 2. But even if there is no dot there, there's still a limit. So let me show you a picture of that. Example. Find limit as x approaches 3 of g of x. Okay, I'm going to give you a graph again. So let's just put 3 right here. Doesn't matter. So there's my graph. Okay, so this is y equals g of x. And then let's put this down here. So let's call this 1, 2, 3, 4, 5. So let's call this 5. So that makes this 2. We'll put a dot right there. Okay. Now, if I try to evaluate this limit as x approaches 3, what do? Well, the instructions say trace the graph of f of x towards x equals a. Trace the graph. That's the key. Trace the graph. So if you're on the graph over here and you trace the graph, you end up right there. And if you're on the graph on the other side, on the right, and you head towards x equals 3, you end up there. So from both directions, from left, from right, you end up right there at that dot. Well, not a dot. You end up at that empty circle, right? So what's the limit as x approaches 3? 5. Okay. So what about that dot? The dot at x equals 3, y equals 2. Well, it doesn't matter. It doesn't matter in terms of the limit. So for evaluating the limit, this doesn't matter. When finding a limit. Okay, so there are two things that are true about this graph. So on this graph, so for this graph, here are two things that are true. Number one, if I asked you what is g of 3, the answer would be 2. Right? Because 3, 2 is on the graph, right? That's 3, 2. So g of 3 equals 2. But for the limit, as x approaches 3 of g of x, that is 5. Okay, so you can have a limit, the limit's up here, but the function value's down here. All right, so a limit and a function value are different things. In order to get the limit, you actually have to trace the graph the way I did with those pink lines. Okay, and that's how you get a limit from a graph. It's pretty easy. Now, something you have to be aware of, though, is that I traced this from the left and from the right. And you actually have to be able to do that. If you can't do that, then there is no limit. So formally, what we'll do is we'll say this. So if you trace the graph from one side, so there are what we call one-sided limits. We have the limit as x approaches a, and you put like a negative sign there of f of x, and that's what we call the limit of f of x as x approaches a from the left. I can't even read my own writing. How is that still there? From the left. Okay? And so you use that little negative sign to indicate from the left. You also have the other one, x approaches a from the right of f of x. I'm not going to write all that again. I'm going to say limit as x approaches a from the right. Right? So right and left. Okay, so you use a plus sign for the left and a minus sign from the right. Why do you use those? Show you. Right? If you have an A here, just think about it. On the right side over here, on a number line, positive numbers are on the right and negative numbers are on the left. So that's why plus means right and minus means left. Okay? Now, because of that, you can evaluate left and right hand limits and get different answers. So you can have an example like this. Put it right here. Okay, so there's a function. I'm going to call it f of x. And we can evaluate two limits here. So we can evaluate the limit from the right and the limit from the left. I guess I ran out of room, so I'll come down here. Limit as x approaches, what are we, 5? From the right of f of x. And we also have the limit as x approaches 5 from the left of f of x. Oh no, that's fine. Okay, and so when you're evaluating those limits, you just do exactly what we did up here, but you do them separately. Once from the left, like this, once from the right, like this other one. So let's do this one first. So this 5 plus, remember plus means from the right. So that means you're on the right side of 5. So you're up here somewhere. And you head towards 5. So that's from the right. So what y value do you get to? Hopefully you can see that the answer is 2. Now let's do the other one. So we have the limit as as x approaches 5 from the left. So if you're on the left side of 5, you're down here somewhere, and you head towards 5. So you trace the curve, you end up there. What's the y value? It's 1. So that's the limit from the left. So you have limit from the left and limit from the right. Now the question is, what's the limit, right? Because we have here limit from left, limit from right, and before we even talked about those, we just did regular limit, right? We just did a regular limit. So what's the regular limit for that one that we just did? Answer, it doesn't exist. So here's a theorem, I guess. I'll call it a theorem. Theorem. If the two one-sided limits as x approaches a give you different answers, then the two-sided limit, which is the normal limit, limit as x approaches a f of x, does not exist. Okay, so on this one that we just did, the right-hand limit was 2. The left-hand limit was 1. If somebody asks you, what is the limit as x approaches 5 of f of x, you say, does not exist. Okay, because if you look at the graph, well, think about it. What would your answer be? You're supposed to trace the curve, but you trace the curve on the right, you get 2. You trace the curve on the left, you get 1. So what's your answer, 1 or 2? And the answer is neither, right? You have to get the same answer twice, and then you have a limit. Okay? So one-sided limit, two-sided limits. Are both not that bad. Okay, you just trace the curve. And that's all you have to do. So you have to do that, a few times on the homework, and it's pretty straightforward, to be honest. Now, once you have an idea what a limit is, then you need to be able to evaluate it when you don't have a graph. So let's say limit from a table. All right, so let's say we want to do this. Let's say we want to evaluate, let's say, what do I want? Okay, I was trying to think of something and I couldn't, so we'll try this one. We'll just, it'll be pretty simple. So evaluate the limit as x approaches 3 of x squared minus 6. 6? Yeah, that's fine. No, it's not fine. 7. Okay. So let's say evaluate this using a table. Okay. Now, if you're going to see this on the homework, they're going to give you a table, and I don't have a table, so I'm going to have to come up with the table myself. Okay, so here's what the table will look like. So they give you a table, and they say x, and then they say f of x. Okay, now think about this. We're supposed to be tracing the curve as x approaches 3. Well, we don't have a curve. So how are we going to approach x equals 3, right? If you think about what we're doing up here, what you're doing is you're getting closer and closer and closer to 3, right? I don't know why I used the highlighter. You're getting closer and closer and closer to 3, right? Or sorry, closer to 5, right? Like this is 5, like if 5's here and you're starting out here, you're getting closer to 5, and you get to 5 in that empty circle. How do we get to 3 if we're approaching 3? Well, all you have to do is say, well, what if we did this? What if our x values went 2.9? That's kind of close to 3, right? but we need to get closer to 3. 2.99. Okay, that's pretty close to 3. Can we get closer to 3? 2.999, right? Now that's really close to 3, so maybe that's enough. Okay, now that's only on the left-hand side, right? Think about a number line. 3 is here, right? So all the numbers over here are like 2.9 something, and all the numbers on the right are like 3 point something. And then 3 is in the middle. So 2.9, 2.99, 2.999, those are all on the left. We also need some on the right. So how will we do it? Well, maybe we do this. 3.1, 3.01, 3.001. Those are getting closer to 3 as well, right? And so you'll have a table like that, and you'll have the numbers just, printed in the table for you. So I'm just going to calculate these real quick. So you have, let's see here, do I have a square button? That'd be nice. Sorry, 2.9, enter, 2, 1 to the x, 7 minus, okay. So this is 1.41, if I did that right. I don't know if I did that right, actually. So we get 1.41, and then for this one, I get 1.9401. This one, I get 1.994. Okay, and now let's do the others on the other side. 3.1. I get 2.61. .061. Oh, sorry, 0601. .006001. All right, so there's your table. Now, you're given this, right? Normally you wouldn't have to calculate this. Now, where are the two values that are closest to 3, right? So think about this. 2.9 is not that close to 3. 2.99 is not that close to 3. What is close to 3? This one, right? 2.999 is the closest to 3. Now do the same thing for these. This is kind of far away. 3.1 is kind of far away. 3.01 is closer. What's the closest? 3.01. So which are the ones that are the closest to f of x? This one and this one. Okay? Those are the closest to 3. Sorry, closest to x equals 3. Right? I'm looking at the x values, not the f of x values. Closest to x equals 3. All right. Now, if you're going to try to do this limit here, you have the limit as x approaches 3 of x squared minus 7 equals. Now what you're supposed to do is look at those two highlighted numbers, the 1.994 and the 2.006. And you're supposed to say, well, if we kept doing this and get even closer and closer and closer and closer to x equals 3, where are those two numbers going, right? And just think about it just by looking at the looking at these, right? 1.41, 1.94, 1.994, right? What's the next number? 1.9994, probably. And then look at these. 2.61, 2.06, 2.006. What's the next one if we kept going and following this pattern? We would get 2.0006, right? So if we kept doing this in the table, where do you think x squared minus 7 is going? Hopefully you can look at that table and say, I think it's going to 2. Right? Now that's a guess. But it's a good guess. And it's a guess that's correct. Okay? And that's how you do a limit from a table. You try to see where the numbers were heading towards. Where the numbers are heading towards. And if they're heading towards the same number there, that's your limit. Okay. What's next? I think what's next is some basic properties of limits. Okay, so let's see. Assume the limit as x approaches a of f of x and the limit as x approaches a of g of x exist. Okay. Now here's some properties. Number one property. What if you have to do the limit as x approaches a of two functions added together? Well, it turns out that if you have to do the limit of two functions added together, you can do them separately. The limit as x approaches a of f of x, do that, and then you just add it to another limit. So you can split up a limit and do it that way. Now, what if it's subtraction? Well, if it's subtraction, it's actually the same. So I'll just put a minus there. Okay, so addition and subtraction, you can split it up like that. What about multiplication? What if you have to do the limit of f of x times g of x? Well, same thing. You can actually do the limit of f times the limit of g. So that's nice. What about division? What if you have to do a limit of f over g? Same thing. You can do the limit as x approaches a of f of x and then divide by the limit as x approaches a of g of x. However, you have to be careful because you're not allowed to divide by 0. So this is if it's not 0 on the bottom. If it's not 0 on the bottom, then it's okay. All right? Let's see, what else can we do? Well, there's another property. If you have the limit of as x approaches a and you have f of x to some power, so I'll say like a, like that. I don't know why I use that. I'm going to use a b. Like that. Turns out you can do the limit as x approaches a of f of x, and after you do the limit, then you can do the power. That works out. What else can you do? You can do, well, here's a couple basic ones that are useful to know. So if you have the limit as x approaches a of x, what do you think that limit is? Limit as x approaches a of x. How about a? Is that easy? That's easy, right? But think about this. Once you have that, that means automatically, if you have this now, the limit as x approaches a of x to the b, it's automatically a to the b. And that's not really its own rule, right? That's just combining what I called rule 5 and rule 4, right? That's from those two together give you that rule 6. Okay, what's another rule? Here is one more. What if you have a limit as x approaches a of a k, where k is a constant? Okay, that's a little bit tricky. So x is going to a. But, you know, k doesn't care. K doesn't care. Right, there's no x's there. X goes to a, but there's no x's. So limit as x goes to a of k, where k is a constant, is just k. All right, so I just wrote down a bunch of rules. What are you going to use them for? Well, you can use them to evaluate simple limits now. So I'm going to do one in detail, and then we'll see why you don't want to do them this way. So evaluate limit as x approaches 2 of, let's say, 3x squared plus 5. Okay? And I'm going to use the rules that we know. I'm just rewriting it. 3x squared plus 5. Okay. So I'm going to cite the rules. Normally I wouldn't bother, but this is our first time. So I'm trying to evaluate the limit of 3x squared plus 5. Well, those are two separate terms being added together. Well, what does Rule 1 say? Rule 1 says if we're taking the limit of an f plus a g, we can do the limits on each function separately. So I should be able to take this and say, well, that's the limit as x approaches 2 of 3x squared plus the limit as x approaches 2 of 5. And that's by Rule 1. Now, if you look at the notes in Newton Alta, then you know the rules might be numbered differently. Like what the rule is numbered doesn't matter. Okay, but I'm calling it Rule 1 right here, so that's what it is. So we split it up. Okay, now there's multiple things I can do from here, but here's what I'm gonna do. Oops, I left off a rule. Well, technically I didn't, so I should have had it though. So like if you combine Rule 2 here, so if you combine this rule and this rule, so if you combine rules 2 and 7, then you can get rule that I guess is number 8. If you have a limit as x approaches a of k f of x, it turns out that you can just take that constant and move it outside of the limit. And it's for the same reason as Rule 7 there. Right? X may be going to a, but k doesn't care because it doesn't have an x in it. So you can pull the x out. Why do I do that? Because I want to do it right now. So if I use Rule 8, then I can move the 3 out front. I was going to do two things at once and I didn't. So I'm going to erase that and move Rule 8 there. Okay. So that was Rule 8. And then what we want to do is one more rule. I want to deal with that x squared thing. So let's apply Rule 6 here. limit as x goes to a of x to the b is a to the b. What that's saying is you can just plug in the a for x. Okay, so what rule was that? Number 6. So if I apply rule 6 here, I just take that 2 and I put it in for x. All right, that's rule 6. All right, now what's the limit as x approaches 2 of 5? Well, 5 is a constant, right? So that's rule 7. When x goes to a, the k stays k. So x goes to 2, but 5 is just 5. And that is rule, what, 7? 7. So what's the limit here? Well, we're just working this out. Now just add the numbers together, right? 2 times 2 is 4. 4 times 3 is 12. Plus 5. So 17. All right. Now, that was a fairly significant amount of work, right? A shortcut is if f of x is a polynomial, you can just plug in x equals a to evaluate the limit. So what's that look like? Limit as x approaches, what was it? 2 of 3x squared. 3x squared plus 5. So how do you do this? Just plug in x equals 2. So you get 3, 2 squared plus 5, which is 17. And that's it. Okay. Now, why does that work out? It works out because polynomials don't have any weird stuff going on in their graphs. So think about when we were doing this based on graphs, right? Where are the graphs? So where does something not have a limit, right? A case like this one, where the left-hand side is doing one thing and the right-hand side is doing another thing, that's the case where the limit doesn't exist. Well, how does that happen? It only happens when you have piecewise defined functions and stuff like that. A function like this function, it doesn't have a left-hand half and a right-hand half. It's a smooth curve. It's a parabola. So it turns out that the graph doesn't have any holes in it, and so you just plug in the number and it's going to be the same answer. So technically a limit is not plugging in 2. But for a polynomial, it's the same answer, right? So that's only if f of x is a polynomial, then you can plug in the x equals a to evaluate the limit. Okay. And that will save you a little bit of time on your homework. But you should understand that you do that after you understand what a limit is. Okay? Let's see here. There's no way to pause that, is there? Okay. So what's going to happen now? Okay, one last thing. I was trying to see if there was one more thing I was missing. I felt like there was. Here's another way to use these properties. They'll tell you a limit like this, and they'll tell you another limit. And then they'll ask you for something like this. They'll say find limit as x approaches 1 of f of x plus 3 g of x. All right, and the point of this is just to make you use the rules. Use the rules of limits. Okay, so that means I'm going to apply several rules at once. And if I apply several rules at once, I can make it look like this. Limit as x approaches 1 of f of x, it's one thing, plus 3 limit x approaches 1 of g of x. So hopefully you can see what rules I applied, right? I split up the sum, and then after I split up the sum, then I took the 3 out of the second one. Okay? So you apply the rules, you get here, and then the point is that they told you what this limit is and what this limit is. And they're here and they're here. So you just fill in the numbers. So what is the limit as x approaches 1 of f of x? According to what they gave us, it's 2. And then plus 3 times the limit as x approaches 1 of g of x. What's that? Well, they told us it was 4. So 2 plus 3 times 4. So it's 14. Okay. And I really feel like I have reached the end of what they're going to ask you to do in this homework. So I think that's it. Okay. So we are done. And I will hit stop.